Here are the answers for the section 9-1 homework. Number 1, if f of x is equal to 2 to the x power, evaluate f for these different x values. So input 3 where x is. We get 2 to the third power, that's equal to 8. Now input 0 where x is. 2 to the 0 power, that's equal to 1. Now input negative 2 where the x is. A negative exponent is a reciprocal, so this is 1 over 2 to the 2, and this makes 1/4. And now input negative 1 where the x is. 2 to the negative 1. Again, a negative exponent is a reciprocal, so this makes 1 over 2. Number 3, evaluate this expression. We could type this on our calculator, but it's not necessary because we can do the meaning of the numerator and the meaning of the denominator just in our heads. Let's work with the denominator first. When an exponent is a fraction and the denominator is 2, that is the same thing as a square root. So 4 to the 1/2 power makes a 2. And then we can apply the numerator of our power and go 2 to the 3, getting an answer of 8. Number 5, we could type this in a calculator, but we don't have to. Apply the meaning of that denominator right there first. What is the cube root of 27? That makes a 3. And then we can go to the negative 1 power, which is 1/3. Number 11, find the value of b. b is the base of this. b to the 1/3 equals 5. So what number to the 1/3 power makes 5? A 1/3 power is the same thing as a cube root. So the cube root of what number makes 5? And maybe by now you know that that's 125. If you don't know that, then you can solve it like an equation. Raise the left side to the third power and raise the right side to the third power. These exponents cancel away, and 5 to the third is 125. Question 13. We can solve this by working out the equation like we just did the last one, or we can try to mentally figure out the number. This denominator right here means the same thing as a square root. This numerator means go to the third power. If you can't quickly get the answer, then solve it like an equation. Raise the left side to the 2/3 power and raise the right side to the 2/3 power. This makes b equals 4. The cube root of 8 is 2, and then 2 to the second power makes 4. For the written assignment, we're asked to write it from radical notation into exponential notation. So this 4, which is the index of a radical, is the same thing as the exponent 1/4. So we have xy to the 5th raised to the 1/4. Here's exponential form. Number 3, same instructions. This is a square root. So to do this, we just need to realize what exponent means the same thing as square root. It is the 1/2 exponent. So here is exponential form that goes with this radical form. Number 7, we're asked to simplify this radical. These don't have the same index. This is an index of 3, this is an index of 4. So what we can't do is just times together the numbers in the radicals. Instead, let's make use of their exponential form. We can rewrite this as 2 to the 5/3 power times 2 to the 1/4 power. And now apply the rule about adding the exponents. This makes 2 to the 20/12 plus 3/12, or 2 23/12. Because the original problem had radicals and not exponents, we can convert back into radical notation. This is the 12th root of 2 to the 23 power. Because we're simplifying radicals, we need to make sure that the radical rules are followed from an earlier chapter. We can rewrite this as the 12th root of 2 to the 12th times 2 to the 11th. And then the 12th root of 2 to the 12th is a 2, and the 2 to the 11th stays inside of a radical. Number 9, we have a third root and a fourth root. So again, the indexes don't match each other. Let's rewrite these in their exponential form. So this is 4 to the 1/3 power times 2 to the 1/4 power. Now the bases don't match, so we can't add the exponents yet. Let's rewrite this as 2 squared to the 1/3 power times 2 to the 1/4 power. I'm taking the number 4 and writing it as 2 squared. This in turn is equal to 2 to the 2/3 power times 2 to the 1/4 power. Now we have a multiplication problem where the bases are the same. So you write the base and add the exponents. A common denominator on these fractions is a 12, so this becomes 8/12 plus 3/12. This answer makes 2 to the 11/12. Like number 7, the original problem was in radical form, not exponent form. So let's put it back in that format. The 12th root of 2 to the 11th power. Number 15, let's evaluate this exponential. The meaning of this denominator of 3 in the exponent is as a cube root. So the cube root of 125 is a 5. And that goes to the -4th power. So this makes 1 over 5 to the 4th, which is 1 over 625. Number 23, we have multiplication and division, and the bases are all the same. So we can use the exponent rules. Keep the base, add those two exponents together, but then subtract this exponent. And that creates 6.3 as the exponent on the 10. Number 27, we want to do the cube root of the square root of 27. That makes the 6th root of 27. If that's not immediately clear, you can change those radicals into their exponent form. The square root of 27 is 27 to the 1/2 power. And then remember how we were doing the cube root of that? That's the 1/3 power. Multiplying those exponents together, we have 27 to the 1/6 power. As a radical, that's 6th root. Number 35, we're asked to solve the equation for t. We can try to work it out mentally, or we can remove the exponent by raising to the -4/3 exponent on both sides. This makes t equals. A negative exponent makes the reciprocal of this number, so 8 to the 4/3. Then, when the denominator of the exponent is a 3, that's like having a cube root. So the cube root of 8 is 2. And 2 to the 4th is 16. Number 37. Hey, let's use that same technique. Raise the left side of the equation to the 3/2 power. That's the reciprocal of this exponent, so that when you times those together, you get a 1. And then raise the right side to the 3/2 as well. This makes x minus 1 equals. The square root of 25 is 5. 5 to the 3rd is 125. And so x is equal to 126. Then number 39, we want to solve for y. The first thing I'm going to do is subtract 6 from both sides, getting y minus 6 equals negative y to the 1/2. The reason I did that is to isolate this term right here so that I can now try to remove that exponent. Raise both sides to the 2nd power. On the left side, we have y squared minus 12y plus 36. On the right side, a negative squared makes positive, and when you times those exponents, they cancel, just leaving the y. This is a quadratic equation, so let's get equals to 0 by subtracting y from both sides. Y squared minus 13y plus 36 is equal to 0. Let's solve this with any of the techniques we know, which include factoring, completing the square, quadratic formula, or graphing. Because this does factor, that's the technique that I'm going to choose. Y minus 9 times y minus 4. 9 times 4 is 36, and negative 9 and negative 4 does add up to negative 13. So the answers are y equals 9 or y equals 4.